Hello, good afternoon, and welcome to this video tutorial, which is going to be on Lab 7-2, which is using the ASPATH attribute with BGP. This tutorial is going to be based off of the CCNP V7 route curriculum, and if you're following along, I've actually changed a couple things. Over on the left-hand side here, you can see AS100. In your lab guide probably shows San Jose, but I like to use Santa Rosa, born and raised. So, and then I've got the customer router, excuse me, the customer AS over here, and I'm just going to call it customer. So let's go ahead and jump in. I've done all the base configuration has been done already, and by base configuration I've set up the subnets for the transit networks and the loopback addresses so that we can focus on the EIGRP setup. So let's go ahead and jump in. We're going to start with step 2, which is configure BGP. So let's get BGP set up. We'll go from user exec to privilege exec into global config, and I'm going to say router BGP 100 because we're configuring the Santa Rosa, which is router R1. So we'll go ahead and put a neighbor statement in here for neighbor 192.168.1.6, and they are in remote AS 300, and this is the International Travel Agency's ISP is how this is being portrayed as part of the lab scenario. And the router that we're on here, Santa Rosa, this is, we'll say this is the International Travel Agency's Santa Rosa, California office, and this is their BGP peering. And so let's advertise our loopback address, 10.1.1. or the network I should say, mask 255.255.255.0. all right, and for the International Travel Agency San Jose office, that is it for our BGP configuration for right now. So let's jump over here, excuse me, to the International Travel Agency's ISP, right? So we're peering, and we're going to go ahead, let's say the ISP in this case is Verizon. So we're peering with Verizon, so let's set up Verizon's config. We'll go from user exec to privilege exec into global config, and we're going to say router BGP 300. And the neighbor statement that we need is 192.168.1, whoops, 192.168.1.5. And International Travel Agency's Santa Rosa office is AS100, so it's an eBGP pairing because we're AS300. And let's go ahead and put a network statement on here to push out our, and there we go, our adjacency has come up. So we're going to put a network statement on here to push out our 10.2.2.0 network, and oh, whoops, missed a period there. All right, and now let's also put in the neighbor statement for the customer, right? And this is just, it's not an International Travel Agency customer. This is a different customer who's peering with Verizon. Right, so it could be any customer you want to choose. It could be, you know, Safeway, supermarkets, or whoever. But it's just another customer that's peering with Verizon. So we'll go ahead and put in the neighbor, and this is a 172.24.1.18, and the remote AS for the customer. And this is kind of walking us down. And the customer is using 65,000. Which is one of the private AS numbers as their AS. And so part of the exercise here with the ASPATH, excuse me, the ASPATH attribute is going to be to filter out that private AS number. All right, so our final piece of the puzzle here is going to be on customer router, which is R3. And we're in privilege exec. We'll go to global config, say router BGP, oops, BGP 65,000, and we're going to put our neighbor statement in here for the Verizon ISP 172.24.1.17, and their remote AS is going to be 300. All right, and then we're going to go ahead and do a network statement to originate our loopback address, or the loopback network 10.3.3.0. Forgot the mask keyword there. All right, and we should have our peering come up, and here it is right here. All right, so the neighbor is up. And let's see where we're going to go next here. So it says verify the routers have established the appropriate neighbor relationships by issuing the show IP BGP neighbors command. So we'll say do show IP BGP neighbors. Right, so here's my peering with the internet service provider, Verizon. And you'll notice that that is going to be the only peering that I have, right? Because this is the customer router, the single connection to the Verizon ISP. So here is the Verizon ISP. So do show, and we'll use the new school syntax BGP IPv4 unicast neighbors. And let's see what we've got here. So here's my peering. My BGP neighbor is 24.18. So this is remote AS 65,000. So this is the customer, right? This is the random customer who just happens to be peering with us. Scroll down, we should have another one. There it is. And here is the Santa Rosa office's autonomous system number, AS100, and that is the IP address, the IPv4 address for that router on the point-to-point interface. All right, so we've checked it all out. So now if I were to type in the command on Santa Rosa here, if I were to say do show BGP IPv4 unicast, right, you can see that we're learning a series of routes here. The 10110, right, that's us, and you can see because it's assigned, not only is it assigned the way to 32.768, but it's also next hop is us, the quad zeros. And then we've got the 10.220 and the 10.330. The 220 belongs to the International Travel Agency's ISP, and the 330, right, what's the origin of that? So we've got the I out here, which means it was originated with the network command, originated in AS 65,000, then came through AS 300, who is the ISP, and then arrived at us. So if we take a look at the picture here, that 10.333 network, and I just noticed there's a typo right there. Should be a little period right there. So 10.331, so it originated here in 65,000. It came up to the Verizon ISP, so put Verizon up here. And then we learned about it from our Verizon eBGP peering. So when that route 10.3.3.0/24 shows up here, it shows that it was first originated in 65,000, AS 65,000, then, remember, read from right to left with the ASPATH attributes, then came through AS 300 to arrive at us. So if we were to take a look here at the customer router, what do you think we would see for loopback 0? Because it's originated in AS 100, it comes up to AS 300, and then the eBGP peering, it's going to learn about it down in AS 65,000. So let's take a peek here and see if that's what it shows. So do show BGP IPv4 unicast. And sure enough, it originated in AS 100, came through 300 to reach us, right? All right, so the problem here, and what we're trying to address, is that we are learning a route that's coming into our autonomous system with an AS number of 65,000. Now, this is a private autonomous system number, and it is not going to be used on the internet, right? These are for private internal use. And so what'll happen is we'll want that to be stripped off, because we don't want this AS to originate from the customer and arrive at another one of our customers, if we're Verizon, to arrive at another one of our customers who just happens to be using that same AS number. Because if that's what happens, when the route shows up at customer B, let's say, and customer B has also decided to use 65,000, it's going to drop that route. It's not going to install that route into the routing table because it sees its own AS path, right, or its own AS number autonomous system number in the ASPATH. And that is the primary use of the ASPATH, is loop prevention, right? So if the customer A in our scenario here advertised this and it got sent out onto the public internet, and for whatever reason it didn't get stripped, another customer who may be using that somewhere in their environment is going to see that and think, oh, well, that originated from my AS, so we're going to get rid of it. And we definitely don't want that to happen. And actually, I'm going to take a quick step back here. So we're being asked to do some ping commands. So it says display the Santa Rosa routing table with the show IP route command. So we're on Santa Rosa, so do show IP route. And again, this is going to be one of those situations where we ping, but there's no route back, so it should fail. So Santa Rosa should have a route to both 10.220 and 330, and we do. And here are our BGP learn routes. And it says ping the 10.331 address. So we'll say do ping 10.3.3.1. Now we know this is going to fail because even though we have a route to the 10.331, the ping is originating from that interface right there, which means that the source IP of these pings will be 192.168.1.5. So if I step over here to the customer who we just pinged and I say do show IP route, do I have a route that will get me back to the 192.168.1.5? And you can clearly see here from the routing table we do not. Now I do have a route back to get to the loopback network of the Santa Rosa router. So again, this is one of these subtleties that I run the ping with no options here in terms of where I'm sourcing my ping from. And if I do that, it's going to source from the outgoing interface, which is the serial 00 interface here, which is 192.168.1.5. Now let's take a look and see what happens if I say ping 10.3.3.1, but I'm going to source this from my loopback 0 interface. Aha! Now it works. And the reason it works here is because the customer router in AS65000 actually has a route back to me. So the previous pings here that failed, they went out and they got to where they were going, but they had no idea how to come back because it was sourced off that serial interface. And the customer router has no route telling it how to get to 192.168.1.4 or to the 1.4 network, because that's a transit network that sits between the Santa Rosa site and the ITA ISP, right? However, it does have a route because we originated this route with the network statement and it's learned it via BGP. So now when I ping, I source it from this address. So when that hits the customer router in AS65000, the customer can see that and says, ah, I've got a route. I know how to get back to you. And now we have success. Again, so just a little subtlety there with these ping commands. All right. So where are we at now? So we're going to check the BGP table from or on the Santa Rosa router. So we're going to say do show BGP IPv4 unicast. So here's our BGP routing table right now. And what do we see? Right? We see that we've got a route installed here. It's a valid route. It's the best route. And again, just because it's got a private AS number does not mean it's not valid. We also know that this third character here, which is missing, can be an I or an E, right? So when it, well, it won't show an E. So it can be an I or it can be blank. If it's blank, that symbolizes that this is learned via external BGP. If there was an I here, that would mean it would be an internal or an IBGP learned route. So the fact that nothing is here symbolizes that these routes are learned via eBGP. Okay, so we see again that we've got this route here that has the private AS number on it. And so the question is why might that be a problem? And again, it's because these are private autonomous system numbers. They should not be used on the internet. Very similar to our RFC 1918 addresses, right? The 10.000/8, 172.16/12, 192.168/16, that those RFC 1918 addresses should not and will not be routed on the public internet. And with the autonomous system number, it's the same thing. If there was another client connected to the Verizon ISP in this case, right, and they were also using 6500, they would see these routes, right, because these are eBGP peering, so they would have these routes come into Verizon. Verizon's then advertising these routes out. And the problem is that when the customer B gets it, he's going to see his AS number in the AS path, and as a result, he's going to assume that there's a loop, and he's going to drop that route, right? Because that is the primary purpose of the AS path, is for loop prevention, to make sure that there are no loops in our routes. Okay, so now what are we going to do? We need to strip this off. And so this is where we're going to go ahead and use a command with our neighbor, our peering command under the BGP config that just basically says remove private AS, because we want to make sure that we take it in, and that's great, but we want to strip this private AS number off of the advertisement from the customer router. So let's go to our ISP, and it'll be the ISP's responsibility here to strip that private AS number off. And where are we at? I'm pretty sure we're in the BGP config, but a router BGP 300. And we're going to say neighbor 172.24.1.18, or I'm sorry, 192.168.1.5. And so what we're doing here is we're configuring the ISP so that it will strip private AS numbers with routes that it exchanges or that it sends over to San Jose, right? So that's our peering, and then we've got remote AS, or I'm sorry, not remote AS, remove private AS. So I'm going to go ahead and hit enter here. So now what's going to happen is the advertisement's going to come in from the customer router. It's going to come in with an ASPATH attribute of 65,000, and then what's going to happen is the ISP is going to strip that when it sends it over to the San Jose router. And so let's do a, we may have to see if it'll cooperate here. Yeah, so we may have to bump this here. So I'm going to say do clear IP BGP star out. Let's see if that gets the desired result. Perfect. All right, so now you can see that the private AS has been removed, so that if for whatever reason, let's say that we had on the Santa Rosa side, we had our BGP peering set up with AS 65,000, that we would accept these routes, because how do we see these routes? We see these routes coming in now as originating from AS 300, not originating from AS 65,000, right? So let's check that out real quick. So, and this is kind of a, we'll go off on a tangent here. So do show, we'll say do show run section BGP. All right, so I'm going to exit out. I'm going to say no router. Whoops. I'm going to exit out. I'm going to say no router BGP 100. And I'm going to say router BGP 65,000. And network 10.1.1.0 mask. So we're going to advertise the same thing here. And set up my neighbor 192.168.1.6. Remote AS is 300. All right. So now I've established a, or I'm going to establish here shortly, and there it is. So it says peer AS is wrong, right? Notification received, because I've got configuration information here on the ISP router. And again, you can see we're getting all kinds of messages. So I'm going to say do show run section BGP, because we're going to need to fix that. So I'm going to say no neighbor 192.168, copy and paste that. And there we go. The adjacency went down, so the error messages should stop. Now let's get the write command in there. So I'm going to say neighbor 192.168.1.5 remote AS 65123, right? So 65,000. So now I've configured, let's take a look at, and there we go. The adjacency is up. Do show run section BGP. Right? So I've got two different eBGP peerings, both using AS 65,000. So let's come back over here now and say do show BGP IPv4 unicast. And are we learning about the 10.330 network? Right? We are not. We're not picking it up. And so if we come back over here, right, you can see that this is on the ISP router, so I'm not stripping anything off, right? And it should be the same with the customer router. Do show BGP IPv4 unicast. He's not learning, the customer's not learning about the 10.1.1.0. And why is that? The reason is that right now, again, there is no remove private AS in play here, right? So here's our current config, and this is the scenario that they're really talking about. So they're talking about a scenario here where I've got two customers, and let me go ahead and pull some of these things out of here. So they're talking about a scenario where you've got the customers, and again, we're just going to say this is Verizon. And we're going to suspend reality here for a second and say that this is 65,000. So this guy's AS 65,000, and so is this guy, right? So the Santa Rosa office for ITA, and then just, you know, customer A. So anything that this customer advertises up here to the ISP, when it gets advertised this way, is going to be discarded by router 1 because it's going to see its AS path or its AS number in the AS path, and vice versa. He's originating his 10.1.1.0 network. However, when it arrives over here at router 3 looks at the AS path, sees its AS number in there, and discards that route. So as a result, neither router, and no, I won't do that. So as they say, do show BGP IPv4 unicast. So neither router, and actually we're on the ISP here, neither router is learning the route because you can see this is the originating AS number. Now this is the ISP, so he doesn't care because obviously there's no conflict here. The ISP's AS 300. So he's going to learn both of these routes. However, when he goes to advertise them out, right, the AS path would show up as 65,300 when going over to AS 100, or 65,100 when going over to the customer. We'll say customer A in this case, right? So that's why these routes are not being learned. And so this is kind of what we're trying to prevent. So let's see if removing the AS, right? So we're in the router config. So I'm going to say neighbor 192.168.1.5 remove private AS. So let's see if when the ISP takes the advertisement it's learning from the customer router and sends it down to the Santa Rosa router for ITA, does this make a difference? And I'm probably going to have to do clear IPBGP star out. And let's come over and see, is the Santa Rosa router learning about the 10.330 route, even though we've removed the private AS. And it doesn't look like it's pulling in now. What we may do, or what I'm going to do actually, is let's do a full clearing here. So I'm going to say do clear IPBGP star, and let's make sure. Because this is the scenario that they're talking about, is that we've got multiple customers with the same private AS. We'll have to give BGP some time here. We have multiple customers with the same private AS, and so we strip the AS off so that it's not going to cause a conflict with another customer. And boy, BGP has taken its time. All right, so we're waiting here. All right, so BGP peering is back up now. And you can see, even though we've stripped it, it's still not learning that advertisement. Right, you can see it's still not learning that advertisement, but is the ISP router picking it up? Do show IP, or do show BGP IPv4 unicast? It is, right? However, it's still not going to get picked up down here at the Santa Rosa router, even though we've cleared the configuration, right? It's still not going to be learned because it's a private AS number, right? And it's not going to get pulled in. So again, even when I stripped it with the remove private AS, it still is not going to get picked up. So let's go ahead, let's clean our config up here. Let me exit out. We're going to say no router BGP 65000. And then we're going to go back and say router BGP 100. And we'll put in our statements, which I should have saved. Give me a second here. And by this point, it probably would have been easier to just pull up the document. Here we go. So we'll drop this back in. All right, and we should have our adjacency reestablished here. Actually, we're going to have to go back to router 4. Do show run section, and there we go. We've got this error that we're going to get. So we're going to say no neighbor 192.168.1.5, and then we're going to say neighbor 192.168.1.5 remote AS is 100. And so now we should have the peering reestablish here. So the peering is up. Let's check. Do we see the routes? Do show BGP IPv4 unicast. So that 10333 route is now back. So let's strip it out with the remove private AS. And I'm probably going to have to do the do clear IP BGP star out in order to get it to reset, soft reset that adjacency. And there we go. And as you can see, the private AS has been stripped off. So now it shows as originating from AS 300. All right, so on the Santa Rosa router, if I were to say do show IP route, are we learning the route? We are, right? And it showed in the table. So it's definitely still there. So now from the Santa Rosa router, I want to say San Jose, we're going to say do ping 192, or actually we're going to ping 10.3.3.1, and if I hit enter, you'll notice it still doesn't work, just like before, right? So if I do it again and source it from the loopback 0 interface of Santa Rosa, it will work. All right. So now we're at step 4. And so what we're going to do here is we're going to use the ASPATH to actually filter routes. So the section starts out by talking about, as a final configuration, we're going to use the ASPATH attribute to filter routes based on their origin. So in a complex environment, you can use this attribute to enforce routing policy. In this case, the provider router ISP needs to be configured so that it doesn't propagate routes that originate from Santa Rosa, right, to the customer router. So any routes that are originating from Santa Rosa need to be stripped out so that they're not advertised to our customer, because the customer doesn't need to know about the routes that Santa Rosa is originating. So we're going to use an ASPATH access list to do this, and basically we're going to suppress the advertising of anything coming from AS100 that is currently going to be seen over here at the customer router. So if I said do show BGP IPv4 unicast, you can see that what's originating from, which of these routes is originating from AS100? Well, it's this guy right here, the 10110, which was originated with a network statement, came into, or it originated from AS100, passed through AS300, and then ended up here at AS65000. So now let's go ahead on the ISP and set it up so that we are stripping out anything that originated from AS100 making its way over to the customer router. So from global config mode, we would say IP. Now remember, you could do like an access list, but here it's going to be an ASPATH access list. So I'm saying IP ASPATH access list 1, and what are your ranges here? So it's 1 to 500, so we'll just say 1, and I'm going to deny, and now I'm going to use some regular expression characters here. So if it originated in AS100, and let's take a look back over here at the pattern that we're looking at here, is 100, 300. So anything that originated, and we want to match that pattern right there, right? So what we're going to say is caret, which means that the string begins with those characters, and then I'm going to anchor it with the $ at the end. And so what this means is that it starts with 100 and then the end of the line, right, or the end of the AS path. And so if we look over here, you can see that we have 300 space 100, and then that's the end of the AS path. Remember, this I, that is part of the origin, right? That is representing the origin, and there's no header here that says origin code, right? But this is a different field. It is not the ASPATH field. So that is our ASPATH field. So the caret says it starts with the number 1 followed by a 0 followed by a 0. The $ says it's the end of that field, the ASPATH field. And so that is how we would specify over here. That's how we say IP ASPATH access list 1 deny, and that's how you say it originated from AS100. Because if it originates from that AS is going to be the last AS going from left to right in the AS path. And this is how we basically pick off the last AS to identify it, to say that it's AS100. Now, just like regular access paths, just like regular access lists, at the end of the access list is an implicit deny all, right? So it's very important that we also place another second statement in here after we deny that one statement saying anything originating from AS100, we want it to be denied. We then need to permit everything else. And now, so here are two more what are referred to as meta characters, right? Regular expression meta characters that are going to be used. Now the period represents any character, right? And the asterisk represents 0 or more of the preceding character. So by putting the period here, I'm saying match any character, And the asterisk says, yeah, sure, match any character and match 0 or more of any character. So this basically says match everything. Okay, because again, we want to permit all of the other AS paths that are trying to come through, right? All right, so again, to review, the character basically specifies that that's the beginning of the string that we're trying to match with the 100 for the AS100. The $ represents that that character is the last character at the end of the field, right? And if you're familiar with Unix, if you're in the Vim editor, you know, the caret is the beginning of line, and the $ anchors it to the end of a line. So very similar. And the period and the asterisk, again, very similar. Matches any single character, and that's the period. And then the asterisk says match 0 or more of that preceding character. So it matches everything and anything, right? All right, so now that we've configured our IP ASPATH access list to strip routes or deny routes that have originated from AS100, now let's go ahead and apply this. So on the ISP router, I'm going to say router BGP 300. And on the neighbor statement I'm going to apply this to, it's going to be 172.24.1.18. And what am I applying here? So it's an ASPATH access list. However, you'll notice there's no access path or access list keyword here, right? So we're going to use a filter list, right? This is different than a distribute list, so we're going to use a filter list, and the number simply refers to what we created with that ASPATH access list. We gave it number 1, and we're going to say it's in the outbound direction, because again, ISP router 2, right? Its neighbor relationship with the customer router is on the 172.24.1.16 subnet. So we're going to apply this filter in the outbound direction going toward the customer. So this is going to strip anything coming from AS100. It's going to basically not install it in the routing table. So I'm going to hit enter. And again, we're going to have to do our do clear IP BGP. I'm going to do start outbound, and let's see if that's enough without tearing down the whole adjacency. And then take a look there where we were learning about the route, right? Originating in AS100, this 10.110/24, we now are no longer learning that. And this is because we've applied that the ASPATH access list. Now, if you think about the two things we've done here, so we did the remove private AS, and then we did this ASPATH access list. Now, they're two very different approaches to two very different use cases. In the previous, or I should say the first use case that we had with the remove private AS, all we wanted to do over here is make sure that Santa Rosa, when it learned the route, or I'm sorry, do show BGP IPv4 unicast, all we wanted to do with that is make sure that when the 10.330 showed up here, that it stripped the private AS, that's 65,000. So we see it as showing up as originating from AS300, right? So that's one use case, but we still learned the route. So the first use case with the remove private AS, it rips the private AS out of there, but we still learn the route and we still know how to get there. The second use case, when we use the ASPATH access list, is used when I'm trying to say, okay, I don't want customer A to see any of the Santa Rosa routes. So it's not just taking the private AS or, removing the AS, it's actually filtering, right, which is the term we use, the filter list term. It's filtering that route from being advertised to the neighbor on which we apply that filter list statement. And so that's exactly what's happened here, right? So if I were to do the same thing, right, and again, this isn't, we'll just do one more example here, and this isn't for you obviously would not do this in this scenario, but we'll do it, see what happens. So IP ASPATH access list, we'll say 2. Deny routes originating from AS300. So then we're going to come back here and we'll put in our permit all. I'm going to go to router BGP 300, and I'm going to say neighbor 192.168.1.5, and that is the Santa Rosa router, and I'm going to say filter list 2 out. Do clear IP BGP star. So now let's come over here and let's see what routes I'm learning. Just as you would expect, right? Because prior to this, the 2 routes that I was learning in addition to my loopback address were the 10.220 and the 10.330, right? We stripped the private AS out, and so these both showed as though they were coming into me originating from AS300, right? So very, very different. I shouldn't say very, very different. Very, very similar to what we stripped when we took out routes originating from AS100 going to the customer router. So let's do one more scenario here. So I'm going to go ahead and say do show run section BGP. And I'm going to say no. Whoops, sorry. Thought I was on the ISP router. So Control A, we're going to say no filter list 2 out going over to the Santa Rosa router. And then we're going to clear BGP. Actually, I wanted to do out, so we'll clear BGP, and that should take care of that. Let's go ahead and say do show BGP IPv4 unicast. And there we go. We've got our routes back. So we've got the routes back. We're still filtering with our ASPATH access list. We're still filtering our route over to the provider, or I shouldn't say the provider, the customer. So one last thing that we can do on the ISP router is let's check to see if I were to say do show IP BGP regex and say caret $100. This is going to show me which routes am I suppressing, right? So this matches, for whatever the regular expression is that we put in there, any of the routes that match that regular expression, right? Or the prefixes in the BGP routing table that match that expression. And so here you can see that we are definitely blocking, right, or filtering out the 10.110 going from the ISP router over to the customer router, right? Okay, so one last thing that we're going to take a look at here is, let's see if we've got, let's pull off the remove private AS. Or actually, was that going to make sense? Hold on one second here. Do show BGP IPv4 unicast. Yeah, so I don't think that that's going to make sense because it would come in as 300. Yeah, so we kind of already, I was basically going to do another filter, but we'll go ahead and cut it off here. So again, really good real world exercise from the ISP perspective to be able to say, hey, I'm not going to advertise customer Santa Rosa International Travel Agency Santa Rosa office routes over to customer A. He doesn't need to see those routes. And then vice versa. Customer A is using AS 65,000, and I'm going to remove that private AS so that when I pass the routes along, that private AS is no longer there. It appears as if it's originated from me. All right, so that's a really nice look at how to set up a filter list with an IP ASPATH access list, and also how to use the remove private AS command within BGP. Thanks so much for watching, and have a great Memorial Day weekend.